A lot of eminence people over here, a lot of enthusiasm, and I see a lot of participation. It's great to be a part of this whole show. Today I'll be presenting one of our projects in the northeastern belt in the city of Imphal. So we've done a project, it's a government project, and it's right now, it's the world's highest polo statue. It's a 122 feet high statue at Imphal. And why I say it's the world's highest, because as a polo sport, you know, the sport of polo originated from, am I audible? Yeah. So the sport of polo originated from Imphal. So if you know, the Imphal says it gave the world the sport of polo. So on behalf of the government of Imphal, so we and the PWD, we created a statue which was 122 feet high and completely of steel. Again, it's India's first statue which is completely of hollow sections, steel and only hollow sections. So, okay. So the client is Public Work Department of Imphal and the project consultant themselves. We were the consultants, for the structural consultants for the project, engineering consultant, and one of the major work done the consultant was the fabricator, which was executed by none other than National Power Engineering Corporate Company based out of Siliguri, Vizag and Jaipur. They have done a phenomenal job. As I go into the slides, you'll be able to see the fabrication work done. So, because it's a short, I'll just try to go through the slides and give you as much as information possible. So this is again a dream project of the Chief Minister of Imphal, Manipur, Sri Biren Singh, and it was it's standing on top of a mountain, on top of a 3-storied high concrete building, on the roof of that, and the total height of the statue is around 122 feet. Now, to envisage this statue, it a little bit in the initial phase, it was a little bit of a challenge because we needed to build a prototype model on ground, scan and digitize them into 3D scanning into form of pixels, then in getting into the structural analysis part. Because if you don't know the framing part and if you can't form the framing, we wouldn't have been able to go ahead with the statue. So this is what you see in the screen is the prototype model which was built on ground. It was digitally scanned 360 degree, and then digital images were created and then framing patterns were created from there. This, again, is entirely built out of hollow sections provided by Tata Steel, Tata Structura, and I'm grateful for their timely delivery and with ensuring every bit of the sections, whatever form we have given has been delivered on site without any delay. So this has two skins. One is our inner skin, which is the main structure, core structure, and then which is the outer skin, which hosts the cladding, which gives the shape to the statue, to the face, to the hair of the horse, to the face of the rider. So you can see there are two distinct analyses which have been done. One is of the horse and one is that of the rider. And once you see these are stat images, but these are formed from the pixel scannings we got in the first stage when we digitally scanned the whole statue. Once we did that, then we could get the proper framing of the statue, because one of the biggest challenges of such statues, such high statues or high structures are wind and seismic. For both, you need to create a level of framing which can actually encounter any wind from any direction. Ideally, wind tunnel testing would have been a ideal situation, but wind tunnel testing was not possible. So we created 32 different load cases of wind to simulate the entire wind tunnel forces on the statue, which means any framing should resist all 360 degrees of forces around the statue at any point of time in any degree. So that was the horse frame, and this is how the core frames of the rider are. Once the core frames of the rider were finalized, then analysis was it became a lot more simpler. And of course, the forces and everything, we took high levels of wind speed where supercyclone zones were considered. And then if you see this part of the framing, so over here you can understand, one is the core frame which is made out of hollow sections, and outer skin is resting on another frame, secondary frame, which is carved to the shape of the entire statue, which means the eyes, the nose, the hair, every part of the statue, the armbands, the anklets, everything. So there were two distinct framing patterns which we had to follow, and we've been doing that successfully.
Mr. Basu, 2 more minutes, please.
Now, this was a cross-section of one of the framing. You can see the inner frame follows a structural pattern, which a geometric, with a definite geometry. But the outer core frame doesn't have a geometry as per the structural frame is concerned. It is based on the curvature or the architecture of the entire statue. So all of these, if you understand that once the wind hits the statue or the cladding, we have to ensure that neither the cladding bends, so it has to be enough to resist the bending wind forces. It should also be enough to transfer the load to the main frame. So both were very important. And then to get that on site, as a structural consultant, it's easy to create the drawings, give it to, but as a fabricator, as a erection specialist, it's very difficult to do such curvature to the precision. Once you do that, this is one of the pictures which you have on screen where the curvature of each of these frames were being done on site. And again, there were vertical framings to support the external curvature of this thing. These are some of the secondary frame statue images on site, which we were while during fabrication stages. So you can understand that this whole statue, one of the key features in the beginning, what we did for the whole thing is that because it's on top of a mountain, the entire team had actually visited the entire road route from the ground to the top of the mountain to understand what is the minimum curvature or the road curvature in the mountain road. Based on that, the trawler was fixed. Based on that, the maximum framing a trawler could accommodate was actually fixed. And that's how the structural design started. So it was not just the structural design and then into construction. It was more into construction and back calculating the structural framing pattern. So if you see this, so this gives us two distinct images of how the face of the rider was created. One is the structural framing and one is the bronze sheeting. So yes, we used a bronze sheeting with phosphorus content because bronze with phosphorus actually is very malleable, which means it can be bent. But again, it has to be enough to resist the wind, but it cannot be so thick that you cannot bend it. So we had a series of iterations done in for the bronze statue, but then after that we ended up with a thickness of 1.5 millimeter.
Mr. Basu,
we use a software called Tekla to
Mr.
detail
Basu,
out the entire stuff, the entire thing, without which it would have been very difficult for us as well as the construction thing. So these are some of the images of structural statue, and to rest this, one of the key points of such statues are the base connections and the base fixity. So you can see the amount of bolts, 50 dia HD bolts which were created, and then during construction embedded in concrete successfully. So these are some of the logistic what we had done during the process of during detailing and construction. This was one of the legs of the rider. So this is the massivity of the whole thing. It was done on the workshop of NPEC, where we did the prototype first and then we got it to site. This is like building the prototype. We had the two erection scheme. One was building the prototype on ground at the site and then erecting it. So erection, of course, had a pattern of erection. First the legs, then the body of the horse, then the alignment with the body, then the alignment with the rider and the horse. So these are some of the statues of the images of the leg being encasted with the beamwork on the top of and ensuring that these forces are actually transferred via the building to the ground.
Mr. Basu, sorry to interrupt, just to finish it fast.
Yes, sir. So these are some of the images. So do I have 1 more minute?
Yes, you can take, but is it already over?
Right, sure. So these are some of the things, and this is how the statue would look like. This is while our entire erection with the statue was done. This is fixing of bronze sheeting on the thing. Inaugurated by our Honorable Minister, Sri Amit Shah, on 6th of January 2023. And this is the entire team of which was worked behind the entire statue. Just a small video on this. Can we just play the video just? It's a small video.
complex to assess the site